Hey there, my name is David Hobbaker, and today I'm going to walk you through a demo on how to control a robot hand, the fingers of it here, with a EEG that is connected to my head. This project has a corresponding report and code to go with it, but I'm just going to show you how to set it up and how it works. And so the first thing, we have this OpenBCI ganglion board here, which has 4 channels on it for the EEG, and that will get hooked up to a few points on my head. One on the forehead, one on the back, and 2 on the ears for noise canceling and just kind of a reference for the area. The brain of this project is a Raspberry Pi 4, and that is connected to the ganglion board by this Bluetooth USB dongle. And so that's how those are going to communicate. Then we have an InMove 3D printed robot arm here that has the 5 fingers that can move, the wrist can rotate, and it has servos here that are controlling all of that. Those servos are connected to a Adafruit breakout board that it allows us to send I2C commands from the one output from the Raspberry Pi to control each of those servos individually. And those just need to be hooked up together on the output of the I2C into the breakout board. When we're ready to start, we'll plug in the power for this to control the servos. I'm going to hold off for a minute on that. But we'll get started with the board here. Once I get that set up, we'll see the neural network that's running on the Raspberry Pi. We'll get signals like these across the top of my screen here to detect the commands that we're going to give. And those commands are going to be based on my eye blinks. If I give one eye blink, we'll see a single spike like this one, 2 blinks, and 3 blinks. And those will be 3 unique commands that the network will determine, will recognize, and will send different commands to the robot hand to actually make the hand move. And so, first, in order to get the EEG hooked up to my head, we need to use a conductive paste that will make the electrodes sticky and also have a better connection to the forehead. So we'll start with the one on my forehead. There is a universal standard for where these should be placed on a human's head. That's called the 1020 system. And the locations are described in the report. But the first one we're going to use is connect one of the analog channels to the forehead, about 1 inch above or off of the center line and above the left eye. I measured before multiple times, but 2 of my fingers is pretty close to the 1 inch. So I just use that to make it easier for placing this on myself. But it's always probably best to have someone else do it most of the time for you, to be a little more accurate. And occasionally, the paste here is usually strong enough to hold electrode on if you don't yank on it. But not always. So you can always use tape or other things to keep it on your skin, depending on whether it's sticking or not. So let's try that one more time. So I found that it doesn't have to be perfectly accurate for this project, but the more accurate it's placed, the better your results will be. And it's not staying. I'm going to have to tape it today. Alright, we'll grab just 4 pieces of tape just to make sure that I can get these attached to my head properly. And we'll try one more time. And when you put this paste on, you want it to be overflowing just a little bit from the electrode so that it has that space to stick. And put this I try to use it without the tape first just because it's not quite as comfortable with the tape on, but it does work a little bit better. So the next one, let's see. So that was 1 inch off of center and 1 inch above the eyebrow. This one that's going in the back of my head, you find the Indian, which is basically a bump on the bottom of your skull, and you go 1 inch above that and 1 inch to the left as well, so similar to the front. And you want to get it touching your skin as much as possible, so try to get it underneath as much of the hair as you can. And I will take this one in as well. And the last two are going on my ears, just for noise canceling and handling our signal. So these may or may not require the tape. And you'll notice I have the wires all connected together with these wraps. That helps the wires, if they get jostled around a bunch, they'll cause extra noise and interference that will interfere with our accuracy here. So that just kind of helps keep it a little more accurate with a little less interference there. And the ganglion board itself just has a battery here you can plug in, so it has it's an isolated unit, which is good because if it's sitting on your computer desk or next to too close to electronics, it will also get interference. So we want to hold it out in our hand or set it in our lap while we're actually using this to keep it separated from those other interferences there. And to charge that battery, you can just plug it into this little USB connector and plug it into your laptop or computer to charge that battery as well. So I'm gonna turn it on here. It starts blinking the blue light to show that it's working. And then that is connected through Bluetooth to the Raspberry Pi. And I will go ahead and plug in the servos for the robot here. And now I'm SSH'd into the Raspberry Pi on the computer here. And I'm going to run, I'm going to run the main.py program that's linked with this project, and it's going to get us connected connected to the ganglion board here, and then to the robot hand. And as it detects all of that, it takes it a minute to load up here, and you might see a few warnings displayed on the screen. Those are normal. And once it finds it, it asks me to give a blink command. When I don't give one, it just goes 0 and nothing happens. But when I give a couple blinks, it will start to switch between the different patterns that we have here. So from the middle finger is sticking a little bit. But this network at the moment is about 80% accurate on its, just because of the training data I had for it was not, basically I just needed to make more training data to get it more accurate, and that just takes a lot of time. But yeah, that is this project running through with controlling with just eye blinks. So enjoy.